Go live. Hello, good morning, everyone. Hi,
Hello,
Jemson.
good morning. Actually, good afternoon from Singapore.
Yeah, for you, it's good afternoon. That's true. That's true. So now, yeah, you need to do your regular check, Jemson. Are we live?
We need about 30 seconds behind. Now is yes, it's live right now.
Oh,
Yes,
we are live right now. Great. So, Jemson, yeah, how are you? How's everything?
everything is. I think everything is getting back to normal.
Okay.
Yeah, it's getting back to normal, and it goes live.
Great. Thanks. Yeah, that's good to hear. It's kind of strange, isn't it? Now, as we, yeah, at least my feeling is we kind of covered the situation with COVID somehow, and now in Europe, this war is starting. Is it's just
Yeah,
crazy, huh?
we
Yeah.
we, we, we have we have quite a big numbers at this time. Very big
Yeah,
numbers.
you have quite big COVID numbers. Yeah, but I think I mean the impact is not that bad. So
Yeah, 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 yeah,
yeah, but
yeah.
still, it's kind of a. I think the German uh, chancellor said it's a black day for Europe, and I would agree it is. So did you realize, Jemson? Do you hear something about that about Russia and the Ukraine, or is this nothing in your
Yeah, yeah,
news?
yeah, yeah, yeah. I think the President Putin has already made the announcement a few hours ago.
Yeah. But this is something you realize in Singapore and in Asia, right? This is
Yeah,
nothing.
yeah, yeah,
Yeah,
yeah,
it is.
yeah,
Yeah,
yeah.
it's a topic. Okay, so yeah, maybe it's good that for the today's webinar, I don't know if you realized it. We used an emoji, and I can tell you, I'm not a very big emoji fan, but we used this heart, you know,
Yeah,
when we announced this webinar, and yeah, but maybe that's a good sign at the day where a war starts. Yeah, we bring a little bit more heart to the community and to the people. So yeah, I'm very excited about this session. Gems in the heart of the sample handling system for the gas cooler. I mean, that also was your thought or your saying, your sentence. Why do you think this session today is very important?
yeah. I think this is something whereby is probably the most in, probably in fact it is not probably in fact it is the most important component in the in the gas sampling system. Whether you want to have a weak heart or you choose to have a strong heart,
Okay.
the impact is just like the impact will have consequences like water carryover. The condensate is not able to drain fast enough.
Mm-hmm.
The cooling effect is not able to produce a stable dew point, and
Mm-hmm.
also the constructions of the heated line entry time, at the point, what is the temperature of introducing the sample into the gas cooler. There's so many things, whereby is the flow is fast enough, all right? Is the cooling capacity, the energy that we design varies from different supplier. All this has to take it into consideration. I thought, within this 1 hour, if
Yeah,
we can share as much as possible.
yeah. I think that's the target. So yeah, let's make our introduction relatively fast so that we can really jump into the important topics we would like to discuss today.
Mhm.
Very good. Yeah, but allow me also, because it's already next week. Jemson, have you signed up yet for the
Yes, I
SAMs,
did.
for the
I
SAM
did.
conference?
Yeah, I
Oh, you
did. I did.
did.
Yeah.
Oh, yeah, that's great. I also have a presentation slot next Friday. and I'm going to talk about future SEMS and its impacts on sample handling. And I can tell you, I'm quite excited about this session because, and this is also something we are going to discuss already today, the future developments of SEMS and emission monitoring. I mean, today we are not only going to talk about emission monitoring. I think we will also discuss the difference between emission monitoring and process analytics in the field of gas conditioning or in the field of gas cooling. But I think there is new developments coming which impact lower emission limits, lower emission detection limits, which will also be a strong or give a strong impact on the sample handling system. So yeah, I think I'm excited about that session. I'm excited to meet that chair, and hopefully we have some good discussions, and hopefully you do not ask any mean questions to me. Okay, just kidding. Yeah, Achima, this year, this time, oh, I haven't changed the slide. Sorry for that. In August, we are in the preparation for our booth. We are very excited to go. To be quite honest, there are some different signals. I just heard that Siemens, for example, is not participating Achima this year. So I think we also see some developments for shows. But I think we have a lot of things to present, and we have a lot of things to discuss. So we are very excited to see you 22nd of August till 26th, I think. Tobias, maybe you could be so kind and post the dates here in our chat, and maybe also the link to the Achema, because we wanted to invite you and say, guys, if you want to, and if you need any support in hotel bookings, in invitation, in paperwork, just let us know. We would be happy to see you and to meet you again in person. I miss this so much, Jameson. It's crazy, right?
It was. I think the last time I visited was 4 to 5 years ago. Yeah, it's
2018. You mean?
Yeah.
Yeah, 2018. Yeah, it's 4 years.
4 years. Yeah.
Yeah.
Time flies.
It really does. Okay. Then just the advice that you will always have the chance. Sometimes LinkedIn might archive our videos here. They will always be available on YouTube. So check out our channel. I think it's growing pretty much, and so I think it's a great platform to look for this information. See, there's your sentence again. And maybe we have to add something. There's not just one sample handling cooler. Actually, it's also the case, right?
Yeah. This is really the real reason why we have a big family of coolers. So many choices.
Yeah.
Many times the market in our business partner was a bit concerned which to choose. Why?
Mm-hmm.
Well, we try to address this along the way.
Yeah, we should. I think that's an important information to share. Yeah, that's how we see it. And there is the emoji, the heart of the sample handling system. Okay. Yeah, but like you said, Jemson, it's essential. It's very important. And this is, let's say, where all comes down short before the analyzer. So also in terms of a protection of the analyzer, to make sure that there's no liquid carrying over to the analyzer, the sample gas cooler has a very important task. And therefore, I think it's important that we take our time today to
Most
discuss
important.
this.
Most important.
Yeah. So the agenda for today, Jemson, gas cooler function. That's more maybe something like a general overview.
Yeah,
We will,
yeah.
like we always do in the past, we will have an PNID, and we will see the different sections, and we will help you to understand. Okay, where is the cooler located, and what are things in step number 2 for new projects in the design stage? What are the things you need to consider? I think Jemson, point 3 is something we can really you can help us with your experience.
Yeah, yeah, yeah.
Yeah, because I think this is sometimes a situation our partners can see
Yeah,
that they come to a place and then the sample handling system is not working, or
yeah.
what is something you need to do there, right?
I shall do so.
Yeah, okay. So I have a list of very mean questions for you prepared here.
You caught me off guard.
No, just kidding. Okay. Yeah. So the main components, and like we said, we would like to reduce our advertisements here. But if we have an overview of the complexity of an analyzer system, it shows the main sample handling components here. So first of all, we have the gas sampling probe, which is responsible for extracting the primary sampling point, primary sampling tub, for extracting the gas sample out of the maybe chimney or stack or wherever the sample has to be taken off. Then we have the big section of the so-called heated sample lines or heated transport lines or analyzer lines. I think there are so many names for this product. And then we are going to reach the sample handling system, or let's say maybe the inner core, however you want to describe this, of the sample handling system. And as you can see, I mean, we will also give you an overview of the different components which are needed in the sample handling system. But main focus, like we said, will be the gas cooler in the session today. Yeah. Jimson, everything's okay, or?
Yeah, I just wanted to bring
Oh,
one
yeah.
heated line, the impact of the heated line that, affecting the gas cooler.
Yeah. Maybe funny story. I always, experience when there's new people coming to the company, and we have like this kind of interviews, and when it's young engineers coming here, this is always a very exciting question for me to ask them. Okay, we have a heated gas sample probe, and in other sections and other sessions, we already outlined how important it is to have 180, 200 degrees C asset dew point and this situation. Then we have a heated sample line. So why in earth are we now cooling? And sometimes it's quite funny how creative they are. Many times they head into the right direction, but I think when you are in touch with a system like this for the first time, you think, okay, why is that needed? And maybe also something which is important to explain here, because we have this very big field of the different type of SEMS systems. We are talking here about a cold, dry, extractive sample handling system. When we discuss hot, wet solutions, also something which is pretty common in our industry, in our markets, we would see similar components like the gas sampling probes and the heated sample lines, but we are not, in this case, we wouldn't work with a cooler, right, Jameson?
Mm-hmm.
Yeah. So what we are here, looking at, and that's maybe in most of the cases IR, infrared, or UV analyzer technology. What would you say in your region, Jensen? Maybe for emission monitoring, the most common analyzer types? Is that something you would confirm?
Still the IR, the cold dry system. So mainly they still using the IR more than any UV, So IR still, I would say, 90% of the analyzers are IR.
Wow. Okay. Yeah. I think what we find here in upcoming requirements. I mean, waste incineration here in Europe obviously is a very big topic, and there you have multi-components you need to measure. And in this case, you need to measure hot, wet. So a cooler would just dilute or wash out all of the components, HCl, HF, which you need to measure. So in this case, but like you said, for signal or for standard measurements, IR analyzer is still very common. And then especially with IR, I think the interference with water is something we will discuss here more in detail, and that's even stronger when we talk about IR analyzer, right? Yeah. Okay, sorry, you wanted to add something?
No, I'm just saying that even saying that 90% of the IR is inclusive the hot wet IR. So it measures all these components, which is correct. So there is no gas cooler, right? So many of them in Asia, particularly, that they are more price sensitive, right? Not the technologies like the European. So many a times it all comes down to the system integration. You see, the system integration, when they really compare the hot wet IR and the cold dry IR, they will have to make a decision whether it's correct or not, right? So at the end of the day, is that in Asia the way we apply it differently from the European.
But I mean the IR or the cold extractive. By the way, Paul from the UK just confirmed that's cold dry IR and hot wet FTIR, exactly what we said. It depends on how many components you have to measure, and I would say if it's this 3 standard components, CO, NO, SO, you wouldn't choose an FTIR because it's just oversized. So that really depends on what kind of measurement you're talking here about. And okay, Jensen, I mean, good thing for us is even if it's a hot wet system, you still need a sampling probe and you need a heated sample line. And
surely
I can tell you the quality of this component really matters. When you have a hot wet system, you just have to ensure that, especially when you measure in environments like the waste incineration, where where you might have higher acid dew points, and every condensate will finally result in dying of your components because there's so much corrosion then. I think this is the field which unites both type of systems, but at the end, the gas cooler, the gas conditioning system is something which is related to, depending on the analyzer technology which is used.
Just to highlight about the sample probes, as particularly mentioned about the incinerator, we ran the show last month in January about the sample probes. So therefore, those members who like to miss this event, you can go back to the YouTube and watch the sample probe, because it's really a question about everybody can produce a sample probe from all, it looks like mechanical, but indeed it is different. It is different in the sense that many a times can the probe really brings the temperature up above the dew point. This is something that many people has overseen, right? I'm not going to say too much about sample probe, but just watch the YouTube last month.
Yeah, that's a good idea, gentlemen. You're right. Thank you for highlighting this. Yeah. There's also a confirmation for what we are discussing here. I really like, so guys, leave us your comments. I really like to have this interactive, and it's just so great to see that you guys are live. I think this is something we would confirm here. Waste incineration is hot-wet, typical application. When we look at SAM's power plants, obviously, are important, and so I think all technologies will remain. We might see a little bit more. I think it's a growing market for the hot wet system. This is something I would say, but I think the cold dry will not disappear, so to say.
So
James,
I
and help us to arrange these different type of products.
I mean, this is a well, I know in back to many of our business partners ask the questions, which cooler are we going to use for which application? All right. So basically, there are a couple of reasons, but the main reason is we really must see that it is a SAM's application or it is a process application. You see, a SAM's application for the emission is slightly different in the sense that for SAM's application, we want the gas that passing into the gas cooler in the shortest time, all right, to achieve the T90, the response time of the dew point. That makes a big difference between a SAM's cooler compared to a process gas cooler, right? So in between this sentence, there are small little details, but this webinar, we just want to say that the SAM's, when we design a SAM's gas cooler, we design in such a way that the retention time in the cooling has to be fastest, so that the amount of soluble gases that wash out is minimized. So it gives the sample to be the most representative. That is how the differentiating from one gas cooler to another.
So for our partners to understand, the BCR product line is maybe more the process analytics, the process measurement product line, and the MAK series is the SAM's product line and maybe the process product line. Is this something we can say like that? You would agree to this?
Well, generally it can be interchanged. It is interchangeable. It's a question of it is not so much. It's not a very critical question indeed. All right, it's only for those people who are very, very particular when we come to a low measuring range. All right, when we come to low measuring range for SAM's, for example, SO2, right, we have to pay very, very special attention about the cooler exchanger. This is one topic perhaps we will touch on in later.
We will. I think that's an important topic. So, Jensen, again, if someone tells you, okay, what is the best cooler for me? What would be your first question?
I would say, any of these, the gas cooler, in the sense that many times we sell our gas cooler, we have no control who is our buyer. We have no control how the system integrator integrates our gas cooler. What flow, what temperature, and what kind of how they construct and how they line up the whole flow configuration, we have no idea. So in order to have a good gas cooler, the gas cooler must able to cushion. We call it a heart. This is why I'm saying the heart is the heart of the gas conditioning, meaning that when the sample are coming in, there are various of different temperature, different water content, all right, and different flow rate. And if we
Okay,
have a
so
strong heart, we're able to maintain a stable outlet dew point. That is what I call it a very good gas cooler.
okay, so that means we cannot answer this question before knowing the application and the requirement of the customer. That's at the end what we need to understand, right?
Well, yes, yes, I would say that yes. Otherwise, you would buy a very expensive gas cooler to cushion all the differences. That is not.
No, no, that's true. That's true. No, but I think in the selection itself, I think it's very important that we understand. Okay, how high is maybe also something. This might be helpful, Jimson. What would you say is the main characteristics for us to choose the right cooler? What are things we need to know from the sample handling system?
Yeah,
I mean, we would need the flow rate is something important to us, right?
I think most important is the dew point and the amount of water in the process, the sample.
That
Yeah,
that, that okay. That means with a dew point, you're talking here about the inlet dew point. That
yeah, yeah.
yeah. Mhm. That means
Both inlet. Yeah.
how much water it technically describes how much water is in the hot wet gas and um, how much flow maybe, and that helps us then to decide, okay, what kind of cooler or of heat exchanger at the end would we choose? Is this
Yeah, yeah. So I think as we in the within the internal we have three types of exchanger. I think
mhm.
for the audience generally, right, that why we have different exchanger, where we cannot see from the outside. Yeah, that is a critical thing that when we design, it's really is about the amount of water that enter
Sorry?
into the gas cooler. That ultimately the gas cooler, the responsibility is to remove and squeeze out this water. All right.
Right.
So therefore there are a few items have to consider. The types of gas cooler which has that comes with the type of exchanger designed for such a high water content. At the same time, many a times, what I have seen is that many people use one type of cooler and all application. One shoe fits all sizes. This is something that is very dangerous.
Yeah, absolutely. Yeah, maybe Jensen, I can give here a short overview as we started with the BCR cooler in the overview. I have a BCR 05 behind me, and maybe that's a good chance here. Bob, Bob, Bob. So I can. Oh no, that's what I did not want. Let me let me just shortly show this. You can see it, right?
Yeah, yeah,
Okay. Yeah.
perfect.
I mean, this is just this is the BCR 05 cooler, and as you can see, this is the ATEX version. So this cooler is approved to be operated in Zone 1 and in Zone 2. So you can see the tremendous size of it, and I can tell you by moving it, it's also relatively heavy. But the thing we wanted to discuss here, and that's a very typical application for the ATEX units, this is a heat exchanger system in here with stainless steel. That means in many situations in our standard SAM system, we will be sucking the probe. But in process analytics, it's relatively common in many applications. We would have positive pressure That means we have pressure in the heat exchanger, and different to the two other models we will talk about here with the MAK10 and the MAK20, we would have a version in stainless steel, and that would allow to operate the cooler even with positive pressure. Yeah. But like Jensen says, in this applications, the importance is that there can be a very high flow, and we have to ensure that even if the flow is very high, the outlet dew point will remain very low and constant. And yeah, this is something we just have to explain to the audience. James, maybe this is something you can explain to the audience.
Well, this is you see, the question is that why gas cooler is set at 3 degrees? Why is 3 degrees? Why not 4? Why not 5? You see, because at 3 degrees it has been internationally recognized in such a way that at 3 degrees, the amount of water that exceeds that coming on the outlet of the exchanger is less than 1% water. All right, yeah. It is negligible. It is, to be exact, it is about 800 ppm. All right, so therefore it is critical particularly for SO2 measurement. Yeah, because
and this is something which shows this diagram here, and this is something when I stepped into this technology, I had to understand this. So in my not technical words, James, we have this situation: SO2, the layer of the bandwidth of SO2 will be in the similar window, so to say. Maybe the word is not super correct, but I think you know what I'm talking about, of H2O, of water. And in this case, the analyzer could not decide, is this SO2 or is this water?
Yeah.
So this is the reason why it's so important that we have a constant and low outlet dew point, because in this case, then the analyzer can calibrate, like you said, Jensen, the amount of remaining water in order to be very accurate to measure the SO2.
Yeah. This is. I mean, I'm a practical person, as you know, from the background. There are a couple of reasons, especially those people are measuring SO2 when the plant shut down after 24 hours, after 48 hours, 72 hours. You can see that on the analyzer side, there are many a times you can see that SO2 they're still reading of certain milligram or ppm. Yeah. So apart from those like memories that carry effect, right? Those are we're going to talk about it when we talk about heated line. All right, let's go back to the gas cooler. This is another possibility of water. It is water that the analyzer is watching and has so-called mistaken it as SO2. This is why even the plant shut down, and there is a presence of water, and they were seeing that, hey, why is there another 10 ppm of SO2? And then they keep on doing calibration, and there's nothing wrong with the calibration, and they do commissioning, and a few hours later it should be 0, but they still show some SO2. That goes into why we talk about the gas cooler today. We are not able to remove the water.
Yeah. Okay. So volumetric error, Jensen, maybe, and then we are done with maybe the theoretical part, and then we can jump into the practical, because I want to show all the demo units I've been preparing here.
Yeah. So you see, we have prepared so much slides. Let's go into the practical, then comes back, because I find that the practical is so much more important. to show them all these slides. Let's move in. I'm sure the audience is excited to see the live demo.
Okay, yeah, maybe you're probably right, Jensen. Maybe we switch over to this. So most important is we always describe this like the engine of a car. Where is the cooling coming from?
Mm-hmm.
And there's two different types. We have both types in our product portfolio. There's the one type, it's called the Peltier or thermoelectric cooling. Jameson, what would you say in your region? Is this very popular or not so popular? Or
I would say, in my experience, is the only country is Australia. Yeah,
they use it?
Australia, because of the import of the fuel R134A, it is not so, inverted comma, as I'm aware that it is not allowed. So whenever we send in a compressor cooler, many a times that we might have to remove the fuel, and then they have to recharge when they landed. So in Australia, they choose to have Peltier. Yeah, but only Australia. The rest of the country, we have no problem.
Yeah, I think, I mean, it's very difficult to say this in general. We know there's many applications. For example, when you do not have such a high inlet dew point, there is not so much water, or when the flow is not very high, a Peltier cooler could be perfectly great in order to protect the analyzer, to protect the system. But we must admit that there is limitations in terms of the environment and in terms of the ambient temperature. So when it comes to higher ambient temperatures, and like I said, Jebsen, here is the engine, the most engine of our coolers. This is a compressor, and this is the compressor cooler. And yeah, it's relatively heavy. I mean, I leave this look like it's not, but yeah. And we have two areas here. There's the refrigerator inside, and we have the cold and the hot part. And I would say the advantage of this cooling technology is that we have a lot of cooling capacity. So in fact, it is that the dimension of the cooling capacity of the compressor is, very strong, and also allows the operation in very high ambient temperatures. I think, Jemsen, we have this also in one of the slides. We entered the information. I mean, this is just another picture which really shows the different configurations we can have. But let me jump to. I know I'm crashing here a little bit the order of the slides. Let me go back to this one here, which really shows that the compressor has a high cooling capacity. Now, as soon as we have chosen the right cooling engine, thermoelectric or Peltier, because there is some applications, for example, when the compressor is moved quite a lot, this is probably not the best choice. So when you need a mobile solution, we would recommend you to choose a thermoelectric gas cooler, because you know this from the refrigerator in your home. When you move this a lot, you have to make sure that it stands for a while, so that you can start to operate it. Inside, so the cooling engine is one of the key components. The other key component, this is what you mentioned, Jemsen, is the heat exchanger. And I prepared here the heat exchanger. Let me just go to one slide where we have the MAK and an overview of the MAK gas family. This is the heat exchanger we use in the MAK cooler. And this is the heat exchanger for the MAK10 cooler. This is the solution for emission monitoring, Jensen. That's what you said, right?
Mm-hmm.
So inside the cooler, you have this is an aluminium piece which is PTFE coated. And this PTFE coating allows also to measure very aggressive gases. And the big advantage of this technology is, or let me first of all describe how that really goes. The hot, wet gas comes in here and it is forced to go all the way down. And then we have the condensate, which comes out here, and the dry gas, which leaves the heat exchanger here. And I would say that there is a very big advantage because this architecture, this patented architecture of this heat exchanger really allows to dry the gas and to make sure that the outlet dew point is very stable and constant. There was one question, I think a very interesting question is, where would you place the thermocouple in order to ensure that there is really 4 degrees C or 3 degrees C outlet dew point? Paul, and I thank you for asking this question. In this technology, and like I said, the MAK10 heat exchanger is a special heat exchanger because we cool from the inside to the outside. So this here is the cooling. This here is connected to the compressor, and the positioning of the thermocouple of the PT100 is inside this cooling element. That means it is placed inside the cooling block, so to say, which is not a cooling block in the MAK, the heat exchanger. It's this copper cooling, which is inside. And we have a very special knowledge and technology in order to measure what will be the cooling or the temperature of the cooling block here. And how do we ensure that we have the 3 degrees C outlet dew point? So this is one question I was hopefully able to answer here. So Jemsen, for the setup or for the layout of the cooler, would you recommend to use 1 or 2 heat exchanger?
I would strongly recommend 1 cooler with 2 exchanger. You see, the reason is that people are investing in a cooler, which is the most expensive component in the sampling system. If we are investing in the cooler with 1 exchanger, if you add a small little price adder to have dual exchanger, that is a big impact on why a dual exchanger is better than 1. It really saves so much trouble, in the whole configuration.
So you would add this as an additional backup, so to say.
Basically, the dual exchanger has several reasons. Reason number 1 was that a dual exchanger allows to going dual stages of drying. All right, a cooler is people think it is a cooler, but the whole effect of a gas cooler is to dry the sample. So they have a double stage of drying. Number 2, it depends on how you position the sample pump. Many a times, if the pump is, I would say, 90%, if I were to look at the past experience from the point of a system integrator, when they get into trouble, then we start to review the problems. I realize that the sample pump is oversized. Nothing wrong with oversized, but if they couple with a gas cooler that's undersized, That is the root of the whole problem. Yeah.
Right.
So to eliminate it, you have to have a dual exchanger to ensure that the flow is able to compensate each other. That is
Okay.
the whole
So
thing behind.
yeah. So standard setup for you would be to place the gas sample pump between between heat exchanger one and heat exchanger two. That would be a
Yeah,
typical
yeah,
layout, right, for you?
yeah, yeah.
Okay. Yeah.
For safety.
Yeah. Maybe this is really something as we shared, let's say, or as we gave this overview of the MAK10. Maybe that's a good idea here also to give an overview of how the configuration of an MAK10 can look like. A pretty good indicator already is, and that how many peristaltic pumps do you have? So in this, because every heat exchanger needs its own peristaltic pump. The peristaltic pump here is responsible to remove the condensate, to remove the water from the probe. And but Jensen, do you know what? I think the configuration of your cooler is better than the configuration of mine, because it really shows all the options we can include into the cooler.
Yeah, 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 yeah. Let me take over from here for a short while. But
Yes.
also like to take this chance to answer a couple of questions. Online now. From Vincent Earn. I agree that the hot wet is used in the incinerator. Absolutely, all right. And then from Pabio, about the H2 in the airstream. Normally, it is really an application. We do not say that we need gas cooler or not. Normally, not. As for H2, we do not use IR. We use thermal conductivity to measure hydrogen. All right. And then for Paul was talking about when you do a calibration check, you need to measure the temperature control. All right. Let me answer you, Paul. The temperature that display on our gas cooler is actually at the after cooling, meaning it's the outlet of the exchanger. That is the temperature that we are displaying. And also to Paul is that we in line with you that some countries in Asia also require to send the temperature to the authorities, all right, continuously, all right, not just a cooling. They want to know the temperature as well. So this is not unusual. Asia is already practicing the same thing. For Adam, from Adam was saying what type of refrigerants are used in this cooler is R134A. Yeah, and then let me see. Yeah, I think I answered all the questions. Okay,
you
guys.
you
Okay, guys. Let's talk about this cooler. I'm very excited to say that this is the heart of the gas cooler. You see, why we say the heart of the gas cooler? When we see a doctor, you get a heartbeat, problems with palpitation, all these kind of things. Water carries over. You need to understand that the whole examination, you need this information, and this information display on our small display computer. You see, now I'm going to address for a new application and also for people who already have to install the gas cooler are facing problem. Let me address all this in a short quickly. Now, this cooler, what we saw that we call it a gas conditioner, which in fact not just a gas cooler, it integrated with a PTFE filter element. Why PTFE filter element? Because it will not affect SO2. It will not absorb SO2. All right. And we have tilted slightly so that the people who from the technicians or engineer, they can easily read the temperature and the flow. You can easily regulate without bending yourself all the way down. In this cooler, we can see that there's one inlet and one outlet. All right, one inlet and one outlet. Why there are two peristaltic pumps is because one inlet and one outlet is for one exchanger. One exchanger has one peristaltic pump to remove the condensate All right. The other condensate in this here is a demo unit. Is a acid dosing pump. An acid dosing pump, if you are talking about the flue gas desulfurization application, the flue gas supposed to be acidic. All right. If you're going through the caustic injection and the flue gas become neutral, so you need to acidify it by using a phosphoric acid injection. This is a demo unit, all right? And then what you see here in this small little display, what's so special here is that it tells you a report card of the heart. Example, when is the time to change the peristaltic tubing? All right, it displays the temperature of the dew point.
Yeah, Jameson, and sorry, Jameson. In the meantime, I also displayed the different options, and this is something which makes this product relatively rich. So you can add all of these options. It's a long list. Jameson and our team will help you to choose the right selection for your model. But I think, that can really help. For example, we have a pre-separator. When you have a super humid, a very high water concentration, sometimes might be useful to operate with a pre-separator, right? Which might be capable to remove already some water. And but James, allow me to shortly take over here, because there's something you mentioned, and this is something I would like to outline also, is the digital solution here in the cooler. As you can see, and this is what you already started to mention. I'm sorry, that's always a little bit difficult for my brain to understand how to move the camera. So we have some information here which shows what is the ambient temperature and what is the outlet dew point. Obviously, we are not measuring the real outlet dew point, but we did a calculation for the cooling temperature, what will be the outlet dew point. So there's not, because to measure an outlet dew point, a humidity sensor is quite expensive, and this is nothing we would bring with all of this. But important is that we also have a lot of information here. We have alarm sensor and then alarm contact, so it's very easy to connect this to your system. And we also have a CAN bus interface. So if your sample handling system, and we see this upcoming as future developments as well, is we will need more information of the sample handling system. And for example, in China, there is some regions and they require to have the outlet dew point, this information from the sample cooler connected to the sample handling system is part of the emission monitoring itself. I think with this technology, and this is what Jensen says, is counting the hours of operations, and gives some very good information, very helpful information. Okay, Jensen, we really managed. At the beginning, we said we are not sure if we're going to touch on if we have enough time.
We're running out of time.
And now we are again running out of time. So unbelievable. But allow us here to show our newest development, because it's an essential development for us in the field of heat exchanger. Jemson, you talked about that the, let's say, requirement for a very good heat exchanger is in the emission monitoring application, constant and low outlet dew point and minimized washout effects. We have to be fair, there will always be a washout in this type of technology. When we talk about standard, let's say standard, or this type of heat exchanger, there is one technology available in the market, and I think it's fair to mention this here. This is the PermaPure dryer. The PermaPure, they don't call it a cooler because they're not cooling, they are drying, which operates with a Nafion membrane. And there would be no, sorry, there would be nearly no washout effect, but the membrane itself, for example, is not resistant to ammonia. So if you have any parts of ammonia, sorry, this will then destroy the membrane. And therefore, it's very important for us to show, because this development of a heat exchanger, maybe also for the audience to share this, is something you cannot, it's hard to tell, because we are measuring in ppm, we are measuring in so low detection limits, and therefore the smallest effects can have a very, very big impact. And therefore I'm so proud of the team that we managed to develop this new MAK20. So what did we do? We analyzed what is available in the market, and then we improved the existing. So here we have a heat exchanger design. This is the cooling block. Yeah. So again, different to the heat exchanger technology we are using in the MAK10, which I have here. With the MAK20, we use a different technology, and this is a so-called jet stream heat exchanger. This heat exchanger, you will see the hot gas comes in here and the dry gas gets out here. And the cooling comes from the outside. So this is the so-called cooling block. And in this case, the temperature sensor will be in this cooling block in order to make sure that we can reach this constant and low outlet dew point. And we are also operating this with a compressor cooler, with this cooling, with a very powerful cooling capacity. And the advantage really is that we managed to reduce the washout rate. In this small diagram, what we are sharing here, it only looks relatively small, the reduction of the SO2. In fact, if you compare this, it's quite some very big percentage in this very low concentration. We're not sharing any numbers here. This is not, we are not convinced of what we developed there, but the washout effect is very much depending on how high is your SO2 concentration, how high is your flow, how much humidity do you have. So I think it would not be very serious to say, okay, we have 10%, 50%, 30%, 5%, 2% washout rate. This is something we would not give you here, but in certain ranges and in the relevant ranges, I can confirm that we improved a lot in this. That gives another overview of this jet stream technology, and it's also very helpful to have a look on the MAK20, which we have here, because the big advantage is that you can remove the heat exchanger. Oops, you see this here, Jensen?
Yeah.
Yeah, you can remove the heat exchanger without opening the cooler. This is sometimes something we heard from our partners and from our customers. I must be very honest, the numbers of replacements of heat exchanger with the MAK10 I can count at one hand, but still the heat exchanger is available, the jet streams are available directly here, and you have the chance you can either connect the heat exchanger with the peristaltic pumps internally, or you can do it from the outside if you want to. Yeah. So this is the different options. The MAK20 also has the connection capabilities, like you notice already from the MAK10, and it can also be equipped with nearly the same options from the MAK10. So I must really say, I think it's a good achievement we made with this new development. All right, Jemson, it's honestly crazy. Time is already gone.
It seems like we have over prepared.
Yeah, we do have. No, but again, it was a great pleasure to have you, Jemson. Thank you for doing this with me. And yeah, I really hope, I mean, we can only touch, let's say, the surface of the topics here. Feel free to contact us, to contact the team. This is just the configurations. And again, maybe Tobias can share the Calendly link from Jemson so that people, yeah, I think this is something super rich that they can book 30 minutes with you in order to discuss the application, to discuss if there's any questions. And yeah, thank you, Jemson, and have a good time and stay safe. And thank you, guys.
Thank
Thanks for
you.
watching. Bye-bye.